Hi guys, welcome to section 3.4, the quadratic formula and the discriminant. Now, you definitely should have learned the quadratic formula in Algebra 1, but you did not have the opportunity to get imaginary or non-real solutions. So we're going to review the quadratic formula, solve, and be aware that some of our solutions may have i's in them. So our first learning target is I can solve quadratic equations using the quadratic formula. The quadratic formula we can use when your equation is written in standard form. So that's ax squared plus bx plus c equals 0. So we have to be able to identify a, b, and c because your formula is this. X equals the opposite of b, or negative b, plus or minus the square root of the expression b squared minus 4 times a times c, and that's all divided by 2 times a. I do want to point out that you can split this into two fractions when we need to simplify answers. So I'm going to write this just so you can see that these are equivalent, but I will be doing them as one fraction and then just toward the end may split them up if I need to simplify fractions. So it can be negative b over 2a. Hey, that's our formula for axis of symmetry, isn't it? Okay, plus or minus the square root of b squared over b squared minus 4ac, and that's over 2a as well. Now, I just have a little note here. Be careful because the equation must be set equal to 0. Just like when we're factoring. So usually we use the quadratic formula when we cannot factor. Example 1, solve each equation using the quadratic formula. Tell whether the solutions are real or non-real. So letter A, x squared plus 2x equals 3. First thing, since it has to be solved equal to 0, we will subtract 3. And I have x squared plus 2x minus 3 equals 0. I'm going to identify a, b, and c. A is 1, b is 2, c is negative 3, and plug this into my equation, my formula. X equals the opposite of b, that would be negative 2, plus or minus the square root of b squared, that's 2 squared, minus 4 times a, which is 1, times c, which is negative 3. And that's all divided by 2 times a. Okay, when I solve using the quadratic formula, I always simplify what's under my radical first. So this expression, and I kind of just write it above the radical. So 2 squared is 4. And then I have negative 4 times 1, which is negative 4, times the negative 3 is a positive 12. So that's actually 4 plus 12. So now I have this. X equals negative 2 plus or minus the square root of 4 plus 12, which is 16. That's divided by 2. Now this is a nice one because 16 is a perfect square. So negative 2 plus or minus 4, all divided by 2. So I wanted to do this one first because I hope you remember we can get two solutions. My first solution would be negative 2 plus 4 and then divide by 2. And my second would be negative 2 minus 4 divided by 2. Negative 2 plus 4 is 2, divided by 2 is 1. And negative 2 minus 4 is negative 6, divided by 2 is negative 3. So we have two real solutions that we could find. They're integers. That was nice. Okay, looking at example B, I have x squared minus 6x plus 3 equals negative 1. Now this one is not set equal to 0 either. In order to set this one equal to 0, I'm going to add 1. And I can add that to my 3. So x squared minus 6x plus 4 equals 0. Identifying a, b, and c, a is 1, b is negative 6, and c is 4. Now plugging this into my formula, x equals the opposite of b, which would be a positive 6, plus or minus the square root of b squared, negative 6 squared, minus 4 times a, which is 1, times c, which is 4. All divided by 2 times a, 2 times 1. Again, like I did in the first one, I always do what's under the radical first. So under my radical, I have a negative 6 squared. Regardless of what your sign is, when you square, it's positive. So positive 36. Then I have a negative 4 times 1, which is negative 4, times 4, negative 16. 36 minus 16 is 20. So what I have here is 6 plus or minus the square root of 20, and that's divided by 2. 20 is not a perfect square, but we do need to use our skill of simplifying radicals. and change that to, remember that's the square root of 4 times the square root of 5. So we're going to change that to plus or minus 2 rad 5. Now that's all divided by 2. Now that's what I was talking about at the beginning of the video when I said you could split this into two fractions, because 6 is divisible by 2 as well as 2, right? So instead of leaving that as a fraction, I'm going to write this as 3 plus or minus rad 5. Okay, because those 2's cancel and 6 divided by 2 is 3. These are two real solutions. You could write it separately if you wanted. 3 plus rad 5 and 3 minus rad 5. Up to you. Those are real because there's no i's. All right, let's look at C. In C, my A term, this is already set equal to 0, so we're all good to go. A equals 4, B equals negative 12, C equals 9. Let's plug it in. X equals the opposite of B, which is positive 12, plus or minus the square root of B squared, negative 12 squared, minus 4 times A, which is 4, times C, which is 9, all over 2 times A, 2 times 4. All right, let's see what's under the radical first. Negative 12 squared is a positive 144. Then I'm going to take negative 4 times 4 is negative 16. Now use your calculator here. It's okay. So now I'm going to take 16 times 9. That's 144. So I'm subtracting 144 from 144, and obviously that's 0. So this is a special case. I have 12 plus or minus the square root of 0 divided by 2 times 4, which is 8. Well, the square root of 0 is just 0, so I really have nothing to add to 12. And I'm just left with 12 eighths, which we obviously want to reduce. Those are both divisible by 4. That's going to give us 3 halves. So my one solution is 3 halves, and that is real. Now notice, my first two, I had 2 solutions. This one only had 1. Probably has something to do with the fact that we were taking the square root of 0. In our last example, D, negative x squared plus 4x equals 13. I'm going to subtract 13 first. So I'm going to have negative x squared plus 4x minus 13 equals 0. Okay, so A is negative 1, B is 4, C is negative 13. Plugging these in my formula, x equals the opposite of b, negative 4, plus or minus the square root of b squared, 4 squared, minus 4 times a, negative 1, times c, negative 13, all over 2 times a, negative 1. So let's clean up what's under the radical. That's going to be 4 squared, 16. And then I have a negative 4 times a negative 1, that's positive 4. Then I'm going to take times a negative 13, and that's a negative 52. So I'm going to take 16 minus 52. Again, I'm just plugging this in my calculator, and I get negative 36. So I have x equals negative 4 plus or minus the square root of a negative 36, and that's divided by 2 times negative 1, that's negative 2. Hey, 36 is a perfect square, but when it's negative, it's going to have an I. So I have negative 4 plus or minus 6i, and that's divided by negative 2. Remember, we can split these into two fractions, negative 4 divided by negative 2, plus or minus 6i divided by negative 2. Negative 4 divided by negative 2 is a positive 2. Now, the negative 2 in the second one, we don't really have to worry about the sign because we have plus or minus regardless. So 2 plus or minus 3i. So that is 2 non-real solutions because there's an I in it. 2 plus 3i and 2 minus 3i. But you can always write it like that. All right, next video will have the discriminant.